Section 5.3 talks about the quotient rule. The quotient rule, as it applies to exponents, looks like this. Again, we're starting with bases that are the same, but this time they're being divided by each other. And their powers can be subtracted to simplify. So if you remember back to the product rule said if we have am times an, that becomes am plus n. Looking for it here to see if I can find it in my pile. There it was. Nope, one more. Here it is. The basic product rule said that am times an was am plus n. So the quotient rule, its inverse, is going to say that am divided by an gives us am minus n. So let's look at a few examples of that. If we have 7 raised to the 4th power over 7 raised to the 2nd power, we can simplify these exponents before we do the problem. So back before we had this quotient rule, we would have had to have multiplied out 7 to the 4th or wrote out all of its factors and then crossed out the common multiples before we could finish the problem. Now, using this quotient rule, we can rewrite this as 7 to the 4 minus 2, otherwise known as 7 squared, or 49. Doing that when letters are involved is still going to look the same way. N to the 12 minus 4 is the same as n to the 8. This one gets a little bit trickier though, because subtraction with negatives, you have to remember the rules you have about operating with integers. So this one says 2, remember that 2 has a power of 1 on it, 2 to the power of 1 minus a negative 3. Well, 1 minus a negative 3 is actually going to be 2 to the 4th, or 16. There's an alternative way to think of this. If you want to use the elevator pass to bring this 2 upstairs, you would end up with 2 to the 1 times 2 to the 3. And then that product rule would apply, where this still becomes 2 to the 4th, or 16. So if your operations with integers are a little shaky, remember that you can always use the pass to bring that number upstairs. In this last example of this type, we're going to have an x to the 3rd over x to the 5th. Now subtraction, unlike addition, is not commutative. So we can't just put the 5 in front and subtract 3 from it. We have to keep the numerator's exponent first, denominator's exponent second. So this becomes x to the 3 minus 5, which we're going to write as x to the negative 2, or 1 over x squared. For this next set of examples, 47 looks a lot like 43, except that we're going to end up with a number that's down in the denominator. So 4 to the 3 minus 6 gives us 4 to the negative 3, which is the same as 1 over 4 to the 3rd, or 1/64. Here we've got a lot of different integers going on, so we'll do this both ways. V to the negative 3 minus negative 5 becomes v to the negative 3 plus 5, which is v squared. Or, if you prefer to use the elevator passes on these two would end up switching places, giving us v to the 5th over v to the 3rd. Then applying our quotient rule, 5 minus 3 also gives us v squared. In the next example, we have an r raised to the negative 3. And it's only the r that that's applying to. So I'm going to leave my negative 2 out front here. And then I have the r minus 3 minus 10 more is going to give me negative 2 r to the negative 13, which I'm going to want to rewrite as negative 2 over r to the 13, so that that exponent, that negative exponent, is made positive.